Hi everyone. My name is Natalie Berkman. I'm the vice chair of the Lifelong Learning Initiative, which is relatively new with the Association of Princeton Graduate Alumni. So I really thank you all for being here for our second book series talk with our amazing Princeton Star author, Giannis, who's written this very exciting and timely book. We're really lucky so far with these talks. They've been relatively intimate occasions where Princeton stars like yourselves can meet and discuss recent work by other Princeton stars. So feel free to have questions. The way we'll organize it is I'm going to give a brief introduction of our speaker. Then Giannis will take over and give a 35-minute presentation of his book, assuming you haven't read it. And then we'll open up the floor for questions. And no questions are off limits. Giannis is super enthusiastic to share all of his amazing insights about algorithms and governance with everyone. So I know I've got a lot of questions, but I'll be sure to let you all ask as well. So just to introduce Giannis, Giannis received his diploma in electrical and computer engineering at the National Technical University of Athens, and then his PhD in electrical engineering at Princeton. So he's held senior research scientist positions at the Strategic Research Department of the Deutsche Telekom Laboratories in Berlin, and has also been an associate professor at the National Institute of Informatics in Tokyo. He was, up until recently, a research scientist at Relational AI, and is currently transitioning into a new role at an academic institution. And his book is called Organization and Governments Using Algorithms, How to Combinatorially Govern Anonymous the title of his talk is How to Combinatorially Govern Anonymous Queens and Kings. And so with that, I will leave the floor to Giannis. And so, yeah, please enjoy.
Okay, thank you, Natalie. So let me just go ahead and start. Okay, so in preparing for this presentation, I often felt like I am in the movie Terminator. I am going to propose some kind of artificial intelligence to save the world from robot armies. I think artificial intelligence is cool. GPT-4 has flirted with me, and I can prove that if you want by making my logs public. My book is a mathematical/engineering approach to governing organizations. I will cast governance as a combinatorial optimization problem, and I will specifically use computers to solve it. My approach is in sharp contrast to hierarchical governance. I present algorithms for replacing hierarchies. The subtitle of my talk is How to Combinatorially Govern Anonymous Queens and Kings. This directly puts my talk in Princeton's ballpark. Princeton is a campus full of anonymous queens and kings. I invite you to think of this term as a lyricism. I will not define it during my presentation, but I will come back to it at the end of my talk. So what my book is about, the problem my book is solving. Consider two employees at a high-tech company. Let's call them Alice and Bob, like in cryptography. And suppose a new project emerges, which is how to solve an equation. Suppose further both Alice and Bob would like to solve the equation and that the situation is mutually exclusive. So the standard approach used in organizations to solve this problem is to put in the picture a superior who will delegate the equation to one of Alice or Bob. So in our case, the superior clearly seems to steal the thunder, but this is not the only limitation of this method. For example, there have been various instances and very visible instances of gender discrimination and favoritism in corporate governance. These are special cases of what we call corruption. Fighting corruption has been an important desideratum in political governance. In this sense, you can think of the algorithms I will propose as anti-corruption techniques. You will see that they are fundamentally robust to this. I will present algorithms that work even if a subset of the actors are entirely corrupt. What is at work in this governance method is the exploitation, the hierarchical governance method, is the exploitation of an architectural bug in corporate governance. And by extrapolation to other forms of governance. In my book, I discuss justice as a software debugging system. So this is the approach I'm comparing against delegation by human. And for scalability reasons, there are delegation hierarchies whose nature highly depends on who you put at the root. So for example, if you put Aragorn, you get a prosperous society. If you put Sauron, you get a Black Death society. An example of a delegation hierarchy is a Weberian bureaucracy. This is the model of the organization used ubiquitously around the world. For example, in Germany, in Greece, in the United States. There are differences. In Germany, it is pretty efficient. In Greece, it's highly dysfunctional. In the United States, there is a ubiquitous trend for the adoption of flat hierarchies. In my opinion, this is a very primitive model of organization. So I think the story easily goes back to Leviathan and way before that to Aristotle. So I think that Weber was a great social scientist, but he was a very bad engineer, and I will explain over the next few slides what I mean by Weber being a bad engineer. There are examples of systems not governed hierarchically, like the internet and Bitcoin. There is a level of hierarchy in these systems. The principles that guide the designs as they were designed by their architects. For example, the architect of the computer is von Neumann, of the internet are Vint Cerf and Bob Kahn, and the architect of Bitcoin is famously anonymous. But I want to focus on organizations, not these engineering systems. There are organizations that are not governed hierarchically, for example, various open source software movements. However, it has been observed that even in such organizations, hierarchies inexorably develop spontaneously. Athina Karatzogianni, the editor of the series where my book was published, has studied such implicit crypto hierarchies as she calls them. The terminology she uses in her papers on crypto hierarchies is a bit hard to penetrate for an engineer, but if you manage to get past that stage, reading her papers is rewarding. For example, you will get an understanding of why there are so many versions of Linux. Athina's approach in her books and papers is more like positive science. She tries to understand what actually evolves in non-hierarchical organizations like open source movements. The approach in my book and in this talk is a normative engineering approach. I propose what ought to happen. So let's see what I propose. I will focus on a narrow but very important aspect of my solution. So mathematically, a hierarchy is a directed acyclic graph where vertices are actors and arcs point to the flow of delegation orders. And a fundamental limitation of this approach of a hierarchical governance is accountability. Although every actor is accountable to their parent in the hierarchy, the root is entirely unaccountable. And this is a single point of failure at the root of the hierarchy. In security systems engineering, deploying a system with a single point of failure vulnerability is a complete no-no. Do not think that this vulnerability is innocuous. Visible instances of the exploitation of the single point of failure vulnerability are World War II and the war in Ukraine. Hitler and Putin are institutional hackers in the same fashion hackers subvert computer systems. There is something spuriously similar happening in the war in Gaza, but I will thoroughly and rigorously discuss this later in the talk. So in this talk, I care about correcting the single point of failure vulnerability. Let's then get to motivate what I propose, institutional engineering. I will propose mostly one algorithm based on a primitive that I call accountably anonymous delegation. So we have from hierarchical delegation to accountably anonymous delegation. It's accountable, there is a defensible logic, and anonymous. There is no human liable for this logic, for their decisions, not the logic. So mathematically, again, this is the problem I'm trying to solve. On the left-hand side, there are the actors who are going to perform organizational tasks. And on the right-hand side are roles, projects, tasks, equations. And the objective is to do a matching between the actors and the roles. I claim that the combinatorial structure of this problem is impossible to grasp in the human mind. So I specifically use computers to solve it, unless you are a savant, perhaps. And I'm not sure if there exists savants who can handle this complexity. So one contribution is my book is Artificial Intelligence Governance. In my book, I first present an algorithm that one can think of as hardcore artificial intelligence, whose goal is to discover true talent. Such submission to an algorithm is slightly better than submission to a hierarchy, but we are not there yet, I think, with this method, algorithmic method, but perhaps there is hope. Talent, as Perlbach, the Nobel laureate, tells us, talent fulfilled brings the deepest contentment that an individual can know. So perhaps there is hope, but being reduced to your talent is a problem. There are better things we can do, and let me give one example of something better I also designed. So the main contribution of my book. I present an algorithm that will try to stabilize what actors like to do with what other actors think they are good at. The evaluation from other actors resembles academic peer review, and no academic is pleased with academic peer review. So this is an opportunity to co-design both organizations and academia. And how is the stabilization performed? Using a stable marriage algorithm. So in this algorithm, there are n males and n females. Each male ranks the females according to his preferences. Each female ranks the males according to her preferences. And the objective is to do a matching such that there is no male-female pair, such that they both prefer each other against their current partners. So this is the stable marriage algorithm. And in addition to that, there is cryptography to protect confidentiality in the system, and rank aggregation in social choice theory to enable diversity in the reviews. So the idea here is that the superior intellect, the superiors, should design the magic, the algorithms, such that actors perform well magically, and they should work together as equals in the system, no hierarchies. I will name the other character Friedrich. The principle behind my design is paraphrasing Einstein. Actors should be as free as possible, but no freer. So we can think about two extremes. One extreme is everyone does what they like, absolute freedom. So there are prestigious places, especially in the United States, where this principle is used to design organizations. However, I would say that if you take a random organization and apply this principle, you will get a rabble, a mob. For example, if you take Greece and apply these principles, you will get back Greece again. That's what I think. The other extreme, opposite to the absolute freedom, is the Weberian bureaucracy. There is only one root that makes the important decisions, and the rest of the actors are subordinated to the Weberian, to that actor. So I claim that my algorithm can strike a balance between these two extreme approaches, and that it has an innate ability to decongest the rabble. So let's look at an example. So we have our actors, Alice and Bob, and two equations, equation 1 and equation 2. First, Alice expresses her preferences over the equations. For example, she wants to do the first equation more than the second one, and that Bob also expresses his preferences in the same fashion. So we obtain congestion at the first equation, like there is congestion in a city. And I should note that perhaps it is important that they never disclose their preferences to each other. And the algorithm can handle this cryptographically. Now, equations must express their preferences toward the actors, but equations don't have a mind of their own. So what is going to happen is we're going to put the actors, including Friedrich, on each equation. We're going to put Friedrich here, and we're going to put Friedrich here, and we're going to put Alice here and here, and they are going to express their preferences over which actor should get assigned which equation. But if we put, again, Alice here, we have a question. Should Alice evaluate herself? And where it isn't, then there is no best answer to this question. And we're going to have Bob and Friedrich also evaluate Alice. So let's see exactly what is going on here. Let's represent the system state. We have Alice, represent her with A, Bob with B, and equations 1 and 2. And we obtain the system state after the evaluation process. So these 1 and 2 here are Alice's preferences over the equations. 1 and 2 are Bob's preferences over the equations. And we have here the preferences, let's say, of Friedrich. We have AB from the perspective of this equation. This is the perspective of Alice. This is the perspective of Bob for the first equation. For the second equation, again, Friedrich, Alice, and Bob. And then we run rank aggregation here. This process here is rank aggregation. And this process here is rank aggregation. And we obtain preferences of the equations over the actors. And then we run the Gale-Shapley algorithm to do the matching. In fact, we do a cryptographic version of the Gale-Shapley algorithm, and the main property is that no one ever discloses their preferences over the evaluations, but the system is nevertheless accountable. So you see that Alice and Bob have an opportunity to be strategic in their decisions, should they be. So the US Constitution prohibits strategic voting. So ranking is a generalization of voting. Prohibits strategic voting in elections. In Greece, for example, there is no such prohibition. Which is best depends on where you are. These are wonderful topics for exploration. So, with having given you the idea of what I propose in my book, I will do a rather long conclusion. So, some remarks about something that motivated me to write this book about Greece and Germany. So I would say that Greece is an outlier of Western civilization. And I believe the reason is that the Weberian bureaucracies are fundamentally dysfunctional in Greek society. The fundamental difference between Germany and Greece is that in Germany you love your superior, whereas in Greece you hate your superior. I'm not saying this happens always. What I'm saying is that this is the default behavior. Neither approach is good. In Germany, you get immense power at the root of the hierarchy, and in Greece, you get a society, for example, that killed Socrates. I say let's think about how to strike a balance. In the recent financial crisis in Europe, European institutions demanded that Greece submits to the system of organization of the Weberian bureaucracy in the European Union and to the German hierarchy. So my motivation for writing this book is to say that I don't think it makes sense to submit Greece to such a system of organization. We can do better, and what I'm presenting in my book is thorough evidence that we can do that. So I will also try to make some comments about what is going on in Israel. Please keep this picture in mind for the next few slides. As we think about organization, we can think of a subset of the actors of the organization being devils or demons. You can, for example, think of the devils participating in the organization, if thinking of the situation in Israel as Hamas. So let's get straight to the war in Gaza. This conflict is institutionally far more complicated than World War II and the war in Ukraine, but observe how Prime Minister Netanyahu is conflated with Israel, leading to a recurrence of anti-Semitism. Why do I say this? I think that Netanyahu is trying to hijack American support effectively against Israel. This is an omnipotent spiral inflicting suffering and death to Palestinians and Israelis and soon to be others. The situation is similar in Europe, where European countries are trying to hijack American support against Putin by unilaterally escalating the war against Putin. In my humble opinion, European leaders do not understand why the US is not sending troops in Ukraine. In this regard, Europe and Netanyahu are certainly on par against America. I think we need protocols of engagement in military conflict. In my humble opinion, Prime Minister Netanyahu will be liable for a possible crisis of unprecedented proportions against Israel only because he is trying to secure Israel. But please think, what does it mean to eliminate Hamas? Pretty soon Hamas will be hiding in Iran, I think. I will propose something that will require extremely hard work and does not eliminate Hamas, but I strongly believe that it is tenable. You don't have to trust me that it makes sense. You can check for yourselves that these ideas are meaningful. But I will not propose a simple solution which you can apply tomorrow to secure Israel. I propose we build Byzantine fault-tolerant algorithmic delegation systems. Byzantine is a term used in distributed computing to mean an immensely powerful, infinitely intelligent, but corrupt and disgruntled individual. Byzantine fault-tolerant means that the computing system continues to operate correctly in the presence of such Byzantine individuals. Imagine what a Byzantine fault-tolerant government in Israel can do. Political decisions are robust even under insider presence inside Israel of Hamas. In my humble opinion, Israel and Palestine would be better off under a Byzantine robust bilateral governance algorithm that algorithmically ensures hardness of going to war. That would be a generalization of the cryptographic protocol used to fire nuclear weapons. Imagine a protocol that is used to fire war rather than arbitrary hostilities. Designing secure mutual governance go-to-war algorithms is wonderful future work. So I don't think it is will be ever in the foreseeable future be possible to do a mutual governance with Iran. Therefore, before deploying Byzantine fault-tolerant algorithmic delegation systems in Israel, we need to think about how such systems fare against delegation hierarchies. And I had a wonderful question in one of my dry runs for this talk, which I gave at IMDEA, about what ground truth is to do performance evaluation of what I'm proposing. So let me respond to Lydia with recasting mathematics to athletics. So suppose a national state builds an infrastructure of stadiums, and they build one basketball court and one tennis court, and there is a bunch of athletes. What is the ideal ground truth situation in this setting? Who should play basketball and who should play tennis? I don't think there is a clear answer. I think the answer depends on which philosopher you ask. So, a word about the university takeovers. I wish there were also takeovers to help Greece against the recent European financial crisis. But I think it is better not to have any university takeovers at all. I'd humbly encourage intellectuals to hijack academic thinking with their ideas, rather than universities and musical artists to hijack our conscience with their creations and videos. Let me finally add that Israel has been accused of destroying Palestinian infrastructure, especially having bombed universities. In the earnest, I only care about lives having been lost rather than the infrastructure per se. Please think, what kind of universities do you need to educate anonymous queens and kings? That is something the Palestinian and Israeli political leaderships ought to think about, granted they find themselves agreeable to what I have been discussing above. And one final thing, out of true respect for his intellect, I would like to kindly ask Prime Minister Netanyahu to please help us secure Greece. I think it is definitely a clear and present problem. Everyone cares about Israel, and no one is paying attention to what Turkey is trying to mount against Greece. So, applying these ideas in practice is a hard engineering problem. I would say that there are two ways to go ahead and approach that. I call them the Oppenheimer approach and the Tolkien approach. It's fortunate that they both have vivid cinematic representations. The Oppenheimer approach consists in lining up or perhaps drafting delegations of experts and expert committees. I don't believe we should do that. The Tolkien approach consists in experts voluntarily lining up behind a Frodo, who was hardly an expert. I would say that the internet was designed in this fashion that is using the Tolkien approach, Frodo being Vince Cerf and Bob Kahn, and the Fellowship of the Ring being intellects of terrible depth that were trying to help them. The motivation for my book was to put an end to the crisis in Europe. You can think of me as a Greek trying to do something about Greece. You can also think of me as an American Princetonian observing something fundamentally wrong happening and trying to do something about it. What I observed was committees of delegations of experts involuntarily, I hope, destroying Greece. My book was what I decided to do about this. From this point on, I am volunteering to become a Greek Frodo. The question is in which venture? I believe the problem is delegation hierarchies. I propose to cast them in Mount Doom. The ring of power of delegation hierarchies destroyed Germany in World War II, and it is currently destroying Russia in the Ukraine war. Let me expect as a theorist similar failures might happen in beautiful China. I'm not saying they will necessarily happen, but there is a high risk. I'm not so much worried about the United States because their political leadership obeys to reason. They can be convinced, but over a longer time span, of course, there is risk. As a Frodo, I would like to acknowledge my Athensshire. It is the Athenian suburb of Melissia. I would especially like to acknowledge two coffee shops, Avaion and Brucha. Thank you for your hospitality. And now let me get to the final conclusion. Let me say a few words about my book first in the sense of what is in the manuscript. In my book, I have tried to retain the creative character of how ideas emerged. These polished and mathematically precise equations that I showed did not emerge spontaneously, rather it was a slow process leading to their formulation. And I decided not to add a level of academic polish in my book. In trying to retain this creative character, I may sound to some people slightly insane, but I think this is okay. Einstein says that for an idea that does not first seem insane, there is no hope. So I believe there is hope here. To do all of this hard work, I propose the institution of an academic discipline of institutional engineering under the maxim, God is an operating system. This aphorism is not mine, it is actually but by one of the very few prodigious musical artists I know. Frankly, I do not know any other more prodigious musical artist. So frankly, God is an operating system is more like an abyss rather than an aphorism. Thinking what institutional engineering is from the starting point gives powerful thought experiments. So I asked in one of my dry runs a first-year undergraduate student at a university in Athens what he thinks God is an operating system means. And he thought about it for a second and he said, of course, I know what it means. It means that we live in a simulation. And he started being worried that perhaps we do not have free will. I tried to appease him. So coming back from the anonymous kings of the Greek coffee shops to the anonymous queens and kings of the Princeton campus, as a student in Greek high school, I became acquainted with the fundamental principle of organization of the Greek nation, namely that Greece serves the Greeks rather than the other way around. I believe this principle is already in effect at Princeton. In addition to serving the American nation and all nations, I believe Princeton would explicitly proclaim that it is already serving the students and faculty members in its mission statement. I believe the order of events is important. I believe Princeton University should be first and foremost serving the APGA, then the universe, and then everything else. So APGA and Princeton University, thank you for this great opportunity, and I'm happy to take questions. That's it.
Yeah, very interesting talk. Thank you so much. And I actually come into this talk with something very specific in my mind. Right now, oh, by the way, my name is YU. I am a 1995 chemistry graduate student.
Nice to
So
meet you.
right now, I am helping two nonprofit organizations. As you can imagine, nonprofit is very, very different as how we observe the profit or the nations. And I do run into the governance issue, and I become very interested in how you articulate how the algorithm is helping us, and you know the Oppenheimer approach versus Tolkien approach. I think at this moment, we have been using one of the organization has been in nonprofit organization has been in existence for 10 years, very small with just board members and one employee. And we adopted the Oppenheimer approach because we have those delegations with one pointing to, you know, the rest of the board members or the employees to say, you do this, you do that. And we run into issues for sure, as you can imagine. And now we're facing in this situation that we're trying to solve the situation that we're running into. And I'm hoping that you know the way you're thinking about you know governance of the organization, the approach, the algorithm. We're too small to be using an algorithm, but I think the you know the underlying the fundamentals probably will help us.
That is
Yeah.
fantastic to hear. Yeah, I'll be happy to offer any possible feedback. I can try to be as helpful as I can if you want to do that.
Yeah. Thank you. Very helpful.
Thank you.
So I see Andrea and Alex both have questions. Maybe I think I saw Andrea's hand first.
Sorry, shall I go?
Yeah.
Hi, Giannis. Thanks so
Hi,
much for
Andrea.
your talk. I have a couple of questions, although probably not too well formed. But regardless, so do you liken your system of governance rather, is it consistent with a command economy, or would it be more consistent with the free market? So I'm wondering have you considered how monetary incentives fit in, prices, incomes, et cetera, right? The realities that, we already have as an initial condition, right, in our world. And especially when you are considering the application to be quite wide, you talk sometimes about applying it to the level of society and not just a small organization. And then the other question is a little more general. So how would you treat the random, unexpected events, earthquakes, war, COVID, right? How could an algorithm foresee all of the potential possibilities and be able to manage them without using some daily discretion?
Thank you for this question. So the first question, I can think of the economy as a system of organizations where they compete in the market. Keep the market as it is, fixed. Don't change anything about markets, but change the organizations from hierarchies where only a very small number of people benefit within the organization, where there is unequal distribution of wealth within the organization, and try to think about how to evenly and fairly, according to principles of what I call in my book rational justice, according to contribution, distribute.
So enact laws that are going to adjust the pay of CEOs and those in power. Is that how would you implement that realistically?
So my book is about mathematical abstractions. I have not really designed the institutions, but I can extrapolate. The CEO is the root of the hierarchy of an organization. What would be the new role of a CEO under my algorithm? The CEO will not be doing delegations. The CEO will have to perhaps design new problems. It is not clear. I haven't thought about it specifically, what the CEO would do, or whether you would need a CEO. It is not clear. But what you do, if you don't think about the CEO, you can think about organizations in the economy. Don't change the economy at all, the markets. You mentioned about the command economy. I'm not sure what you mean by a command economy, but I say don't change anything
Communism?
about markets. Sorry?
Communism, you're going to enforce rules about how everything is allocated. This is now devoid of the price system, right? And the incentives that we have in the free market.
So communism is based on a strict delegation hierarchy without any principles of rational justice, how to allocate fairly the output from the organization effort.
So you want new rules of allocation is what you're saying.
So in principle, we can think about new rules of justice within an organization if you apply this society-wide. So what I emphasize in my book is justice according to contribution. So you can think about the algorithm I presented as being executed in time steps. Time step 0, time step 1, time step 2, and in between there is some process for evaluating your colleagues.
Yeah.
And keep going.
I would say, under perfect competition, right, it is a result that workers are paid their marginal product, the value of their marginal product. So that's a way, like you say, paid according to the contribution. Maybe think a bit more about whether, your biggest concerns are imperfect competition and forces of monopoly that drive us away from perfectly competitive market structure. Perhaps that's something you might want to think about, just from the economics perspective.
So let me put it this way. Everywhere you see in organization a hierarchy, I claim that this algorithmic abstraction has a place to think about replacing it with that. So a command economy would be something that would be entirely antithetical to the spirit of my book, for example.
Okay.
And regarding your second question, I had thought about the answer before, but now I don't remember what the answer is. So how would it deal with shocks?
Unforeseen events.
Yes,
How would
shocks.
an
Yes,
algorithm,
yes, yes. Let me think about it for a second.
Right, because as you said, Bitcoin manages very well without discretion, unlike, you know, the Fed, which uses daily, you know, its discretion in conducting monetary policy. Bitcoin does very well, but Bitcoin does not manage the currency for an entire country. It does not react to, you know, economic problems and other
I think
unforeseen events.
I see. So I think we need to measure the response time for a decision to take effect. So I think that the real question here is not whether the quality of the decision will be more meaningful. An anti-corrupt decision will be the most meaningful thing you can get. So right now, what you get is accusations by everyone against everyone that they are corrupt. If you are provably non-corrupt, the quality of the decision is going to be very good. But how long is it going to be until you get to a decision? That, I think that's the only question. I don't know the answer to that.
Rules may prevent, I mean, that's why Bitcoin is so popular in many countries where, you know, the monetary authority cannot be trusted, right? Not to debase the currency. But at the same time, rules, laws, or algorithms have to be able to foresee all problems, right? They're written ex ante beforehand. So that's a challenge, I would say. No one predicted COVID. Well, not many of.
Okay, so let's think about this situation, unpredicted COVID. So what would be the response to COVID? So what would you do to defend against COVID
I'm
using
saying
this
some discretion can be valuable to be able to make judgments, you know, good, responsible judgments that haven't been, you know, coded previously. Otherwise, we're always weighted by the past and past experiences that determine our algorithms. And this may prevent us from being able to respond quickly and in the best optimal manner, however you want to define optimal.
So if you delegate one expert to handle the COVID situation, you think that it will be more meaningful and faster?
I'm just saying some events are unforeseen or perhaps unpredictable. And then how are you going to have a rule? You know, when you write a program, you have all these if-then statements, right? You may not really be able to foresee some problems is all I'm saying.
Okay, so I think my intuition from what you're saying is that you perhaps so what the algorithm actually does is not really if then else. It's not so if then else is the hardcore AI governance algorithm, but if then else with provable guarantees. The algorithm that I propose is not really if then else. It's more like you combine what you like in the algorithm. There is an emotion. It is an algorithm, but it is emotionally, it's empathic, let's put it that way. It's an empathic algorithm. It's not really the cold-blooded if then else, because you express what you like. So this is the problem with the hardcore AI governance. So there are algorithms with really great performance guarantees and fantastic analysis, but right now they cannot factor what you like in what you do. They're going to submit you to the mathematics of the decisions and how well you perform, but these are entirely non-corrupt. there is absolutely zero chance of corruption. For the algorithms, the empathic algorithm I propose, you have to do like the Byzantine fault-tolerant algorithmic delegation systems. You have to do, they are not, and there is a possibility of corruption, but it's more like in security engineering. You have to calculate the cost of an attack. So perhaps, so how is it going to work out? So how is it going to handle COVID, let's say? To be honest, I don't know the answer exactly how it will handle COVID, the shocks like COVID, etc. But I don't think that the response time is going to be. I used to have a friend at Princeton who said that from the first implementation of a system, you can get a performance that is a performance boost that is 1,000-fold. So even if it takes long in the beginning, you can improve 1,000 times less.
Okay, thank you. I don't want to take all the time here, but thank you.
Yeah, that was a really interesting question. Really interesting. Oh, both of the questions, super interesting answers. I know that we've got Alex, who's been raising his hand for a while, and John Gallant has put a question in the chat. So let's start with Alex.
I'm moving actually in the house. So that was very interesting, Yannis.
Thank
It was
you.
more economics, actually. Had a lot of economics in there than which is you identify an important problem. And the important problem is how do you if you have especially complicated stuff happening, let's say, to give an example, who should be making the final decision? So for example, we're academics, and especially at the business school where I am at, many times you have non-academics making academic decisions, which is a bit, I think, what you have in mind. So that's kind of, or let's say in the UK, they have this thing called the NHS, which is the National Health Service. And in the National Health Service, you might have doctors. Over time, they have been, they're not making many of the decisions because they don't know how to quote unquote optimize. And of course, that creates various issues, basically. So the problem, I think, is well put. I think it is a problem, especially as the work gets more complicated, especially as we have more specializations, high-tech stuff, academic stuff, medical things. What I'm puzzled is, what is your proposed solution? Because it's a hard problem, and then you identify essentially a corporate governance problem. Or if you want to prefer, if you want another name, it's like an organizational capital problem. Or if you prefer, there's a lot of language these days on ESG, the G in the ESG is corporate governance. The question is, what I'm puzzled is, what's your proposed solution?
To which problem? What I showed was the mathematical abstraction. So my proposed solution for corporate governance, for medical things, it's not clear.
So the idea, so you have the two people's hat in your example. You had two people trying to solve an equation, and then they have to have a superior who probably knows a lot less than them about how to solve the equations. And the superior makes decisions, but the superior knows a lot less, actually. And then therefore, it's not obvious that is the optimal way of organizing the solution to this problem.
I think it is obvious that it is the wrong method, in my opinion.
Yeah, but what is the correct method is the question.
The correct method, I don't know. What I'm proposing in my book is something that is definitely worth thinking about. So I presented, so the problem I am solving is you have actors, roles, how to match them. So the algorithm I presented gives a method to perform the matching between actors and roles. I believe this is a highly meaningful way to think about the problem. I'm not saying this is the best answer, but it's a good starting point.
It is. No, I mean, but it is a hard problem. I mean, it's okay. I'll take a look at your, so you propose a solution in your book?
Yes.
Okay.
Yeah, I think the assumption is that Alice and Bob, they're equally equipped to solve the equation, or they're equally capable of solving the
Exactly. So
solution. So there is no difference between Alice and Bob. I think that is a big assumption.
It's perhaps there are equations that Alice likes more, and Bob, there are equations that Bob likes more, and there are equations that are better fit for Alice and equations that are better fit for Bob. And if you have 1,000 equations and 1,000 actors, it is impossible to think about how to perform 1,000 factorial different combinations for the CEO to handle in his head. That's my point. So even if you have, even if there are, it's not just this combination. You don't need to have 1,000. There are many benefits in other situations as
So
well.
I agree with that intuition. What I'm struggling with, well, which is a hard question, is what would be the elements of the solution to that problem?
That the actors express what they like to do. They express what they like to do. And now the equations express which actors they prefer. But how do equations express in that they don't have a mind of their own?
I see.
So
So
you
you're
put-
taking, I see. So you're taking, okay. So let me try to, so you're taking away the subjectivity or unconscious bias, let's say, by putting it in terms of an algorithm, basically, to make the specialization more appropriate. Is that correct?
Specialization more
Well,
appropriate.
like if you know how to better solve a problem, you're more specialized, you're more, let's say, you know how to solve a particular problem better than me, and the algorithm can detect that based on prior data. I don't.
It's a stabilization between your specialization and what you like to do. So if you have a specialization, others will know this perhaps and evaluate you according to your specialization.
Yeah.
But perhaps you want to do something else. You have the option to say, I don't like this one, I prefer to do the other one.
Look, I have to say that I agree with you that you have identified a problem, but yeah, I have to take a look at what, I mean, and it's not obvious to me what the solutions are, but it's a problem that is not only in academia, but in the corporate world as well, especially as you get more high-tech specialized people, basically.
Let me humbly suggest there is a robust suggestion in my book for the answer. It's not just that I identified the problem, there is a robust suggestion for an answer.
Okay, I'll take a look.
Great. And I don't want us to forget, John put a question in the chat. He's having some audio problems, but he says, thank you for your presentation. Somewhat related, have you looked at algorithms to combat gerrymandering, such as the split line algorithm?
Which algorithm?
The split line algorithm.
I don't know what the split line algorithm is.
Neither do I. But do you think that, have you looked at algorithms to combat issues such as gerrymandering, like in the US?
No, I haven't. I have no idea what that is.
Gerrymandering is where they create congressional districts in really weird ways, where the to get a maximum number of voters who will vote the way they want. They create sort of
Wow, that's fascinating.
arbitrary spaces to create the politics that they want. Ultimately, it's a very odd and I think probably uniquely American issue. And I know that you said you were focusing on Germany and Greece, but I think John's question is certainly interesting. I wonder if algorithms could, and because clearly gerrymandering is 100% human thing.
Thank you for the suggestion. Thank you very much for the suggestion. I will definitely look into this.
And yeah, so I think we're basically out of time. Are there any last questions before we let Giannis go? As I mentioned, the recording for this will be available soon on the event page that you all registered on.
Can I make a final comment? Can I make a final?
Just one second. John just put in a comment into the thing. He said, I think gerrymandering fits your model. There are pure mathematical solutions, but people won't necessarily accept them. They want to inject preferences. I think that's a really interesting
I
point.
will definitely check that. Thank you very much.
Yeah, so Giannis, feel free to make a final statement.
So the final statement is that I recently read Andrea's paper on Bitcoin governance using sound and sound economic foundation. And had I known that paper, I would definitely discuss this more thoroughly, perhaps even in my book. So there is this decentralized, like my algorithm, Bitcoin governance system, and she's trying to approach this using sound economic principles, and I had really liked this approach, and just that's my final comment.
Great. Well, thank you everyone again for attending this exciting second talk in our book series. Just so you know, we've got enough Princeton Star volunteers to have a year's worth of programming now. So Giannis was our second humble volunteer. If any of you have written or published books recently, feel free to put your names in. You can send me an email. I'll stick my email in the chat. But hopefully sometime within the next month, probably right after reunions, I'll put out a calendar for the book series over the next year. That way everyone will have a bit of visibility on the events and when they're happening, and we've got a ton of different types of books too. As you might or may or may not have known, the first book was actually a book by a history professor at Princeton Star on this similar topic in scope, but a totally different disciplinary perspective. It was on a historical perspective of the birth of democracy and secrecy, and what that means for a government or a form of government that's supposed to be transparent. And so now with Giannis's talk on governance using algorithms, I'm not sure what we'll choose for our third one, but we've got a huge variety of really interesting books, from memoirs to books about math and music. So we've got a very interesting roster for you. And once again, we really welcome anyone, if you or any of the Princeton Stars you know have written books recently, please feel free to send them my way.
Thank you for the comments in the chat also that I see. Thank you very much for the great opportunity for giving me to present here these ideas.
Very interesting. Thank you.
Thank you.
Thank you very much, and have a great day, everyone.
Yeah, have a great
Thanks.
day. Bye.
Bye.
Bye.